Hey, and welcome back. My name is MrCaproni. I teach AP Stats at Western Hills University High School. We've been going through a chapter on confidence intervals for one proportion z-test lately, and we're going to actually continue that today. This should be the last day that we're going to be wrapping up this whole confidence interval for one proportion z-tests. After this, we'll go ahead and jump right into hypothesis testing. For today, though, our three major things we're going to cover is number one, we're going to go through a little review of what are all the things needed to do a confidence interval beginning to end. So we'll lay it out just so it's easy, concise, one pager, everything right there. After that, we're going to go ahead and actually do a question all the way through following those simple steps. And then at the end, we're going to go ahead and answer the question, what is the right sample size to get? A lot of times people that go out into the real world, they're answering these questions of what a confidence interval is, and they're asked by a company to go out and get a specific confidence interval with a certain margin of error. How do you choose a proper sample size for something like that? So we're going to check out that question and more today. I hope that you learned something new, and I hope you enjoy. Welcome back to AP Stats Day 16. So you think that you're a hot shot and you're hitting the AP test and you see a question on confidence intervals. What do you got to do? Well, let's go ahead and break it down into each step. So, first things first, if you think you're in the situation where you are trying to give an estimate for a population from what you have from a sample, then you are probably in a situation where you're going to be creating a confidence interval because that's when we take our sample information and try to make a guess about the whole population. So, what things are needed for us to get started? First off, just like any of the tests we're going to be doing for the rest of this school year, you will need to check your conditions. All right. So these are your assumptions and conditions. Now, these slightly change for every test that we're going to do, but for the most part, they're all really similar. The first one's going to be the randomization condition. And this one's pretty basic. It just means when you're reading through the question, did it talk about the sample being drawn in a way that was random? Do you think each sample is going to be independent of each other? If that's fulfilled, then you put a little check mark off there. If it even has the words in there like, hey, they randomly chose blah, 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 then guess what? Boom, check. You got that condition covered. Second one we're looking at is the 10% condition. Now, what this says is that your whole sample size must be less than 10% of the whole population. Now, usually this isn't an issue because if we're talking about like all people in America, you would need a huge sample in order to reach 10% of all of America. So a lot of times we don't run into this as a problem. The only time the 10% condition really is an issue is when you're looking at a small population and you're pulling a sample from that population that could make up more than 10%. Rarely the case, but it could be possible, always something to be checking for. The last major one that we're going to be checking is the success failure condition. And this is actually directly tied to the sample size. So in other words, it's saying is your sample size large enough for us to be allowed to do a confidence interval for this? And in this case, all you're checking is sample size times your p hat and sample size times your q hat, your probability of success and your probability of failure. Once you multiply those together, as long as both of those answers are larger than 10, you fulfill this condition. Once you check all of those three conditions, you're good to go and you can move on to the second step, which is going to be identifying your key variables. Now, what do I mean by variables? These are the things that are given to you in the sample. These are the things you're going to be using to create your confidence interval. So what are the major ones we will see in every question? You will be looking at your p hat, which is your probability of success, your q hat, which is your probability of failure. A lot of times q hat is not given because q hat is just 1 minus the decimal form of p hat. So don't feel like you need to see both of those. A lot of times you're not going to see the q hat, you'll just see p hat, and you can just do 1 minus to get your q hat. But if we're plugging things in the calculator, let's be honest, you don't even need a q hat. So you most of the time won't even be finding this. The next major one is our critical value. That's our Z star. Remember, this is the number that we are going to associate with our level of confidence. So if we want to be 95% confident, we're going to use that 1.96. If we want to be 90 or 99, we're going to use the z stars that go along with that. Remember, we call that our critical value. So those come from our chart. Again, though, if you're doing this work in the calculator, you don't have to worry about finding that because your calculator will do it for you. Last thing is our n, and remember, n is just our sample size, which will always be important whether we're using the calculator or not. Next, if you are using the calculator, remember in our TI Inspire, it actually didn't ask for p hat. What it asked for was the number of successes and your sample size. So if you are not given the number of successes, which is what X stands for, your number of successes, you can find it by just taking your p hat as a decimal and multiplying it by n. Now, there is a little trick here. You cannot have an X that is a decimal. So once you multiply p hat by n, the decimal form of p hat, by n, you want to always round that to the nearest whole number. Because if you try to put a decimal in for x into the calculator, you're going to get an error and it's going to shut you down. So make sure you avoid that. Always round your x to the nearest whole number. The fourth thing we're going to look at is to either decide to do it by hand or use the calculator. This is the final step. This is where you're like, I got everything I need. I'm ready to go. You plug and chug it into the calculator. And if I had to put a fifth step here, it's going to be writing out in a sentence what it actually means that you just found. So sometimes it is good enough to just provide the actual confidence interval with the level of confidence. I'm 95% confident that the true proportion is going to fall between this number and this number. But for the most part, you want to write it out as a sentence. You want to give some context back to the original question. We're working for an AP test here, and you know they don't want to see garbage answers. So put some thought into it, write up a sentence, give me a summary of what happened in the question and what you did. So with that said, let's go ahead and try to use all of these steps in an actual problem. We're moving right in. All right, so we're going to be diving right in here. It says, in October 2010, the Gallup poll asked 510 randomly selected adults the question, generally speaking, do you believe that the death penalty is applied fairly or unfairly in this country today? Of these, 58% answered fairly, 36 said unfairly, and 7% said they just didn't know. Percentages add up to 101 due to rounding, so don't freak out. Then they give us a nice little pie chart showing us some of the data here, and the question says, from this survey, what can we conclude about the opinions of all adults? Now, here's the deal. We're working with confidence intervals right now, so that's what we're going to use to answer this question, all right? With that said, using a confidence interval, what are we actually going to be using it on here? Whenever you have multiple data points here, like how we're looking at fairly, unfairly, and don't know, you usually want to run the confidence interval on the largest percent answer. That way you can say, hey, the largest percent of the country is answering this, and you can give that percent as a confidence interval. So in this case, which one's our largest one? The answer fairly is going to be our largest one. So we're going to run our confidence interval using our p hat of 0.58, and that way we can give a good proportion of all of America. It's going to be somewhere around there that we believe answered fairly to this question. All right. So remember, first things first, let's go ahead and go through our conditions. Number one we got on the table is randomization condition. Now, remember, this isn't rocket science. Right up here, it says that these were randomly sampled adults. So guess what? That is all we need. Check. We have fulfilled that one. The 10% condition means that the sample size itself is less than 10% of the whole population. Now, 510 was our sample size. 510, if you look, what is that 10% of? You could just multiply by 10. And you would find out that that would be 10% of 5,100. Now, it turns out there are far more US adults than 5,100. So we are nowhere near the 10% that we need to stay under, which means we are successful on that one as well. Last one, the success fail condition says that if we multiply 510 by 0.58, and if we multiply 510 by 0.42, the two of those should give us answers that are larger than 10. Now, to be honest, 510 times 58% and 510 times 42% QPAD is obviously going to be larger than 10 because you're talking in the hundreds. But just to give you guys a little peace of mind, I'll go ahead and plug it in. We got 510 times 0.58. That's going to give us 295.8, which is obviously larger than 10. We can also do 510 times the 0.42, which again is just 1 minus the 0.58. And that's going to give us 214.2. So again, both of these are larger than 10, which means we pass the success fail condition. Because we've met all three conditions, we can go ahead and move forward with our question. So second step, let's go ahead and identify our variables. Now, it doesn't exactly give us a level of confidence we want to use here. And because we're going to end up using the calculator, I'm not too worried about using a z-star or our critical value. So in this case, let's just assume that we're going to be doing it with a 95% confidence interval. All right. So I know that the question itself didn't do it. So whenever they don't give you a percent of confidence, you should usually default to the 95%. So we'll go ahead and use that, and we'll use that in our final answer as well. But we can plug in these other things. If you look at the question, do we have a p-hat? Yes, we said we're going to go with the largest one of the answers. So our p-hat here is going to be the 0.58. All right. N is our sample size. So in this case, that's going to be 510. And remember, we need our number of successes. In this case, it's going to turn out being a decimal, because if you do 0.58 times the 510, I already told you guys when we were doing the success fail, if you multiply the two of those together, it's going to give you 295.8. So when we are plugging this into the calculator, remember, your calculator will not accept a decimal answer for x. So for number of successes, we need to round this to 296. All right. So at this point, remember, we're looking at a 95% confidence interval. We've met our conditions. We have our p-hat, we have our n, we have our x. We're ready to go ahead and start plugging this into our calculator. Now remember, my class has been using a TI Inspire CX edition, so that's what we're going to use for this video. But remember, you can do similar things on a TI 83 or 84. You just might have to look up in a separate video how to use a calculator like that for confidence intervals. So remember, in order to do confidence intervals, we go to Menu, we go to 6 for statistics, 6 again for confidence interval. And remember, we will be learning all 6 of these by the end of the year. But at this time, we are only using number 5, which is 1 proportion z interval. Now, as we just found out, our number of successes, we're going to use 296. And for our total number of attempts, we have 510. We are indeed using the 95% confidence level, so we can leave that as is, and we will hit OK. As you can see here, it gave us that our lower bound is going to be a 53.76%, and the upper bound is going to end up being a 62.32%. You can see it also gives us our p-hat, 58%, which was given to us in the problem as well, and it gives us our margin of error. So everything's here, so let's just go ahead. We're going to screen grab this and pull it over to our problem so we can write up our final answer. Now I went ahead and popped that over here, and we can see that right there. And we already talked about what the C lower and C upper is. That's just going to be the bottom and top of our confidence interval. So how would we finish up this question? Remember, I said for AP test, you got to be bringing it hard. So you want to make sure that you're giving some sentence that's kind of just going to tie all of this work together. Now remember, for an extended response question on the AP test, you would want to show all this work, even if it's just writing out the 3 conditions and putting check marks next to them. That at least will let them know that you knew you had to check conditions beforehand. A lot of times, if you forget to check the conditions, they will dock you points on the AP test for that. So make sure you have your conditions listed and whether or not you passed or failed them. All right. Now, with that said, going through here, we got our C lower and C upper. Remember, it's they give a question People answered different things. So, how can we wrap this all up? I went ahead and drafted up a sentence that I'm going to use here. It says, with 95% confidence, I believe somewhere between 53.76% and 62.32% of adults would answer fairly to this question. Now, where did those 2% come from? They just came from my C lower and C upper from the calculator. So there wasn't anything really tricky there. And there you have it. That is a confidence interval. So we have gone through this question. They gave us sample information. We put it all together and we came up with a solid answer about an estimate we had for the population. So let's go ahead and start moving on to how do you know what sample size you need to be legit? So let me break that question down for you. Why do I need to pick a certain sample size to be legit? Well, here's the deal. If I'm a real statistician and I go to a client who's asking me to go out in the world, grab a sample, and they want information about the whole population, they want a specific margin of error, they want a specific level of confidence, how do I go about fulfilling their needs as the client? All right. First off, there's not much I can work with in terms of changing our formula here. Okay. We have a critical value, which if they're giving me a level of confidence, I don't change that. That is what it is. Next off, if I'm going out and grabbing a sample, I don't pick the p hat and q hat. That comes from my sample. And if I'm randomly selecting the people like I should be, then I don't get to choose that p hat and q hat. They are what they are. So, how can I create a sample so that I hit the margin of error they want, and I hit the level of confidence they want? Well, the only thing left in the equation that we can change is n, the sample size. So when we're talking about choosing a proper sample size, that's what I mean. How do you choose a sample size to change the equation enough to meet the conditions that your client would want? Now, you could say, Mr. Caproni, why don't we just ask as many people as possible? Why don't we just load ourselves with data? Why don't I just spend all the time in the world asking every person possible? Because in that case, the client's not going to be upset if our margin of error is smaller than what they require. The client's not going to be upset if my level of confidence is higher than what they want. So why not? Let's just ask the whole world. Let me tell you why. It's because it's all about the Benjamins. Look, if I'm running a company here and I want to save as much money as possible and I want to fulfill my clients' needs, but still at the end of the day be making top dollar, then here's what I'm going to do. I'm going to find the minimum number of people that I need to sample in order to get the conditions met. All right. Why would I want to do that? Because every person I'm going out and asking this question to is going to cost money. It's going to cost money for the people that are asking questions. It's going to cost money for whoever's running the numbers that come back from those people. It's going to cost man hours, paper hours, whatever way I'm doing the survey. You have this sample size you can in order to fulfill the client's position. So when we're looking at this question of why find a sample size to be legit, that's why we're doing it. You can see on the screen as I've been talking, it has the formulas up there. I talked about the fact that we can't change a lot of this. So what can we change? It's that n. Remember, we also dealt in a previous video with the whole idea of what if they don't give you a p hat or q hat? They want to know how many you're going to sample up front. You can always default back to that worst case scenario and use zero point 0.5 for your p hat and zero point 0.5 for your q hat, and then calculate your sample size based off of those two numbers. But if a question gives you p hat, then you don't need to do that. You don't have to use the 0.5 worst case scenario situation. That is only if you do not have your p hat. So let's go ahead and check the question they had on here and see what work they do to actually find this n once they know the conversation we just had. So they said that suppose a candidate is planning a poll and wants to estimate the voter support within 3% with 95% confidence. How large a sample does she need? So all they did is took the information they have and plug it into our margin of error formula. Remember, our confidence interval is made up of p hat plus or minus the margin of error. So really, that's the only things we have to work with here. So they went ahead and said, hey, they wanted margin of error to be 3%. That's what they mean by within 3%. So they plug margin of error in as 0.03. Then they want a 95% confidence, which we don't use the 95% anywhere in there, but we do know that the critical value, the Z star that goes along with 95%, is 1.96. Now, nowhere in that sentence does it say anything about p hat or q hat. So they are going to default to using the 0.50, all right? Because remember, again, that's our worst case scenario. So then they go ahead and plug everything in. They got the 0.03, the 1.96, the 0.5 for worst case scenario divided by the n. So how do we go about solving for n? This does use a bit of algebra, but nothing that's outside of the realm of using our calculator. So how can we break this down? There is a rule, if you remember, that says if you have the square root of a number over a number inside the square root, you can actually break that down into the square root of what was on top divided by the square root of what is on the bottom. So that's the first step they did, is they made that differentiation. Then they're able to move that square root n to the other side. Now remember, if you're dividing by something, the only way you can move it to the other side is by multiplying by it instead. So they multiply square root n by both sides, it cancels it out over here, and you end up with what they have in this step right here, which is the 0.3 times the square root of n equals 1.96 times the square root of 0.5 times 0.5. They go ahead and finish it off by dividing this 0.03 to the other side. So that's what you see in this step right here. So they go ahead and they have that, they have our top divided by the 0.03, and it gives us 32.67. Now the only issue is the square root of n is equal to 32.67. So for the last step, they just go ahead and square that number. When you square both sides of the equation, it will give us just n over here and a final answer of 1067. Now, it says here to be safe, you round up. Even though 0.1 would lend itself to you rounding down to 1067, you still round it up to 1068 because 1067 is not going to give you the requirements that the client wanted. So you want to make sure you at least reach their requirements. So you always round this number up to the next whole number, because remember, you can't have 0.1 of a person. We even count people that are missing legs and stuff as whole people. So that doesn't count as a decimal of a person. So always round this up to the nearest whole person. Always go up, never go down. That way you're making sure to fulfill your requirements. So this is a problem that kind of did for us. Let's go ahead and look at trying to do one on our own. So this is a question we've looked at multiple times. So we're going to just kind of rush through it a bit here. It's the Yale George Mason about the scientists disagreeing with global warming or not. Before we were dealing with the 3% margin of error, but they're saying, hey, for this one, we want to keep the 40% as the p hat. We want to keep the 95%, but now we want a margin of error of 2%. So in that case, what is the sample size we need in order to make that change? So when we're looking at this, we need to find our n, and we're going to do that. We can kind of plug in very similar to the example we just looked at. Our algebra was kind of already done for us. Remember, our critical value ended up on top here. The critical value that goes with 95% is the 1.96. We multiply that by what was on the top of underneath our square root. In this case, that's the p hat times q hat. We don't have to use worst case scenario because we have the 40%. So we're going to put 0.4 times our 0.6, which is just 1 minus 0.4. And we're going to divide that whole thing by the margin of error that was given to us. So that's going to be the 0.02. And this will give us n square root of n, sorry. And that answer is going to be, plug all that into your calculator, and you get 48.01. So if we want a final answer here, remember we need to square both sides, square both of those. Let's go ahead and square that in there. And once you square it, it's going to give us that n is equal to 2,300 and 4.96, which means we're going to move this up to a 5 because we always round up here. So in order for us to get the 2% margin of error that we want, we plug in the information they needed. We would need to sample at least 2,305 people, and that will give us the client's demands.
And there you have it, guys. We've knocked out confidence intervals, at least for one proportion z-test. We're going to do more confidence intervals in the future, but for right now, we're going to get ready to jump next lesson into hypothesis testing. Now remember, if you felt behind or like you didn't understand everything that's going on, you can always find all of my videos on YouTube. Just search MrCaproni, no space, no period, and you'll find all the videos up until this point along with this one there. That's going to wrap up our conversation about confidence intervals. I'm really happy you joined us today. I hope you learned something new. And as always, stay fit, stay healthy, and have a wonderful week.